Assalamualaikum and good days. In this video, I will explain to you the analysis of data. What is important information that you need to provide for the data analysis. The first one, the calculations. You should provide the calculation using the correct formula and dimensions. Then you have to draw or plotting a graph, and then the graph must include the title, suitable scale, label axis, the best fit line, and the gradient obtained within with their errors. For further information, you need to refer to the laboratory 0, how to do graph and how to do the calculation using the correct formula. This is example how you want to calculate the graph. The theory of the graph, for example, from the Hooke's law, the theory of the experimental Hooke's law F is equal to Kx, right? F is equal to Kx. So, when we comparing with the general equation of the graph, y is equal to mx plus c. In this case, the c will be equal to 0. So when we make a comparison, for the y-axis is your forces. For the x-axis is referring to your displacement. And the gradient m will be equal to your k. So gradient of the graph m will be equal to your k. In this case, the k is equal to the spring constant. So this is how we calculate the value of spring constant by using the graph. So by reflex with your experimental, for example, the experimental is that you doing is a height equal to half gx squared. So when we comparing it with the y equal to mx, right? So we plotting the graph and then we get the gradient. We plotting the graph and then we get the gradient. The gradient here m. In this case, the m equal to half g. So if we want to calculate the g for the experimental, we equal to 2m. So you have to find the gradient, and the gradient times 2, then we get the calculated gradient. So the calculated gradient here will be example equal to 10 meter per second. When we are conducting the experiment, we are not allowed to give the answer like this. Because not every data that we obtain are exactly. There have a variance with the theoretical value. So you should provide your data, g plus minus data g. You should provide maybe 10 plus minus their uncertainties, data g. So how you want to obtain the data g? You obtain the data g from the graph. We obtain it from the m. Data m. How you want to provide data m? So data m. Firstly you have to draw the maximum line, and then draw the minimum line. Then you draw the base line. So the data m is equal to half data m max minus with the m min. Right? So this is the formula how you want to calculate the data m. So the data m will be reflect the data g. So you need to calculate data m. So then for your calculated g are provided with their uncertainties. This is the main information of the graph that you should include when you're plotting the graph. So firstly, the title of the graph, okay, the label of the y-axis, the label of the x-axis, okay, the scale here, the scale for x, okay, 2 centimeter maybe equal to 0.05 meter. Okay, the label for y, okay, 2 centimeter, okay, is equal to 0.1 meter. Okay, the tips, how you want to draw the best line, the maximum line, and the minimum line. Okay, the tips is, okay, you should find the centroid because of this line intercept at the at the center point. So how you want to calculate the center point? The number of point x. Okay, for example here, the first point maybe 0.07. Okay, plus with the 0.9, plus with the 0.16, plus with the 0.17, then plus with the 0.18, and then plus with the 0.21, for example, 25. Then you get, and you divide it with the 1, 2, 3, 4, 5, 6. You divide it by 6, and then you get the value of centroid at point S is equal to 0.148. And then the value of the centroid at point Y, okay, equal to 0.442. So this point is the central point. So of this line, okay, must be intercept at the central point. So therefore, you can calculate the maximum line, the best line, and also the minimum line. Okay. In your discussions, you must involve the technique that you use in the experiment. You must correlate the finding with the suitable concept that theory that you has learned. For example, you calculate the value of G, right? Okay, the G, this is the concept value that you determine, while the theory's value of G is equal to 9.81. And then the value of G here that you obtain from the experimenter is 10 meter per second negative 2. Okay, you must make a comparison between the calculated value with the theoretical value. How you make the comparison is by the percentage error, or by the percentage difference, or by standard deviations. So, if your data have a variance with a theoretical value, how large the variance? Okay, either it is a range of 1%, or either it range by 10%, okay, either it range by 15%. Okay, the good experiments, it shows the value of the variance less than a 10%. Okay, so when your calculated data have a variance with a theoretical value, so you must provide a possible sources of error. As stated in the laboratory 0, the possible of the sources of error such as come from a random error or come from a systematic error. Okay, these both error will be affected the accuracy and also the precisely of your measurements. Okay, you also have to answer the question correctly based on the right theory formula or give us good explanations regarding to the questions. Okay. For the lastly, the conclusion that you have provide in your laboratory report must concise the conclusion of the experiment. You must reflect back, okay, the objective of the experiment and state the hypothesis of the experiment was acceptable or not. Okay, as I mentioned, okay, you must include it, okay, the uncertainty of the measurement. For example, okay, the force act upon the object is directly proportional to the acceleration of the motion. Okay, this is the hypothesis. You confirm it by the experiment that we can see that the force is directly proportional to the acceleration of the motion. And the calculated value, which is, for example, here acceleration, you also provided their uncertainties of the measurements. So this is how you want to write the good laboratory report in order to achieve the outcome of the code. Terima kasih. Welcome. Thank you for your attention.